Hey, hello. Assalamu alaikum, everyone. I am MD Rimon from United International University, Bangladesh. So, welcome to all of you to a new uh, design tutorial series segment. So, today, basically, I will explain the first tutorial one. So, our outline is we will explain today. We will explain the disadvantage of analog IC design by using square law. All right, square law. So, second of all, we will explain today what will be the solution. So, what will be the solution? It means that how to we can overcome the disadvantage of the analog circuit design by using the square law. So, let us discuss what is the wrong with our conventional design technique. So, whenever we design something in our simulation tool, we need to uh, have some circuit diagram, and by based on the circuit diagram we will design the circuit by using some calculation. So in the conventional design technique we design circuit using square law, right? So the conventional design technique design we are using square law. Okay, so what is square law? We know our famous MOSFET equation or the MOS current equation, that is ID is equals to 1 by 2 mu1 COX W by L into VGS minus VTH whole square. So basically, this is a very old equation. This is a very old equation. And the modern devices that are run very small channel length MOSFETs. So nowadays we using our devices different type of circuit inside the transistors. Size is actually now roughly 10 nanometer, 5 nanometer, 7 nanometer, 6 nanometer. So in this range, so we can say that the MOSFETs are uh, sizing of the MOSFET is actually reduced day by day by using the concept of the Moore's law. Moore's law explained that the MOSFET will be reduced, and the size of the area that will be prominent, that will be very smaller, but inside those area we will implemented millions or billions of transistors because we reduce the size of the MOSFETs. So whenever we reduce the channel length of the MOSFETs, it will arises different type of effects like short channel effect, short channel effects, and then drain induced barrier lowering, drain induced barrier lowering. Right, barrier lowering. Third, the special thing is that the channel length modulation. So there are different type of situation will be arised. We cannot explain all those things by using the square law. So there are many short channel effects we cannot be explained using the square law. So that is the disadvantage of the IC design by using the square law. So let us describe the first outline in details. So suppose you have some design specification. Suppose you have some design specification, and by based on the design specification, let's say uh, you do some hand calculation. You do some hand calculation. So generally, we do the hand calculation before going to the simulator. So whenever the hand calculation will be done, we design our circuit by using the calculated value. We actually design our circuit, and after that, we will draw the circuit or the schematic into some simulation tools, some simulator like cadence. And after that, we simulate our circuit. We try to verify our result, that is actually maintain the specification or not. But the problem is whenever we use the square law, we're using the hand calculation. We're using the hand calculation by using some equations. So those equations comes from the square law, right? Those equations are comes from square law. There are lots of equations we are actually used. But whenever we use the simulator or we simulate the circuit, so the simulator have some personal models libraries. Personal models. So these models are very accurate and very advanced. And the models parameter are included all the MOSFETs effect, all the short channel effect, like everything that they are included. So we design our circuit by using the square law. But the square law, whenever we consider, the equations are actually not uh, explain the all the effect of the MOSFETs. So our rule equation is like you see the ID is equals to 1 by 2 mu and co x W by L into VGS minus VTH whole square. So we use this type of equation for the hand calculation to get the circuit parameter values. So this doesn't include any of the short channel effect, and it is not accurate. So for this reason, the models and my hand calculation, these are actually doesn't match. There are some deviation. They are actually doesn't match. For this reason, whatever we calculate, and the calculation may be very accurate. So whenever we simulate, we can see that our specification and our result, they does not meet. So that's one of the most problem that we are facing whenever we using the square law. The result does not actually match. So at the time, what we do, we change the aspect ratio of our MOSFETs. We tweaking our value. We change the length and width of the MOSFET to try to achieve the These are the specifications. So this is the explanation of the first outline. So we need to design circuit, because if we stop designing the circuit, the world will stop. So for this reason, we need to design and try to overcome some problems and finding some new solutions. So what is the solution? So the solution is that very straightforward and very simple. Number one, avoid the equations. That means all the equations. All the equations. Second, we need a new design procedure or new design technique. So that's I am actually explained now. Through about the design procedure, which include we need the all the effects of the MOSFETs. Like if we arrange a new design procedure, we need to introduce all the MOS parameters. All the MOS parameters. We need those things. Like all the short channel effects and everything we need to understand from the design procedure. And our hand calculations that we will explain the next tutorial video. So the solution is provided by using a design procedure, that will be a new design technique that is called GM over ID technique. GM over ID design technique. So by using the GM over ID technique, this is a special type of technique which consider all the effects of the MOSFET properly. So in this tutorial, we actually covered the two things, that is, what is the disadvantage or the problem whenever we design our IC by using the square law, and why the results and the specification actually doesn't match, because the simulator models and my hand calculations equations, they are not matched correctly, because the simulator models library, they are using the all the effects of our MOSFETs, all the effects of our MOSFETs. But whenever we calculate, we avoid our those uh, effects that are come from our model libraries. So the model libraries and the square law or our hand calculation, they are actually not match. For this reason, the specification and the result, they are actually not match. So the solution is we need to avoid all the equations. We need a new design technique, which technique include all the MOSFET parameters with my calculations. The solution is we will explain a new design technique that is called the GM over ID technique. So the next video, I will explain what will be the GM over ID. So keep with us and subscribe my channel. And with this, I conclude this tutorial video. Thanks for watching.